All right, so looking at number 1, it says determine if the following are one-to-one. So some of these are graphs, and we have to do line tests, vertical line tests, horizontal line tests. Some of these are tables. Some of them are ordered pairs. Who can tell me one that is or is not one-to-one and why? It's like crickets in here. Esme, can you give me one that is or is not one-to-one? Number 5. How about here? I'm going to call them A, B, C, D, E, and F. A is not. Who said that? Why? Yeah. So first of all, it has to be, if before something's one-to-one, it has to be a function. Remember that? It has to be a function first. You might want to write that on here. So as you look at the x values, and we call the x values the domain, I don't have any repeats for the day. I have 1, 2, 3, 4, 5, 6, 7, but in the number of baskets, I have a 17 here and a 17 here. So 17 is corresponding with 2 and 5. That is definitely not one-to-one. Very good. All right, somebody else. You said which one? E. You're saying is or is not a function? It is a function. Why do you say that? Okay, no repeats in the x values. I'm double checking here. And do we have any repeats in the y values? I don't think so. So I think, is that right? Do you guys see any repeats? -7, 8, 12, 8. Ooh. So you got to look at your x values first. And I do see we have an 8 going to 3, and we have an 8 going to -6. Okay, so it has to be a function first. So this one is not going to be one-to-one. Does that make sense now? Does everybody see that? Yeah, you got to check. It has to be a function first. All right, how about another one? What about B? Okay, why not? It works with the horizontal. But you're right. Why is it not? B? Well, that's a graph. It doesn't pass the vertical test, right? So it has to be a function first. Does not pass the vertical line test. Okay? Because it would cut through several times on that one. Wow, well, we got several that are not. Sometimes it's easier to find the ones that are not. And that's what you can do on the test if you would have something like this. Cristobal, what do you say? Is there one on here? Do you feel is or is not? What about C? Yes, this one is. Each input, that's your x value, has one output, and each output has one input. Okay? That one's a yes. All right, we got 2 more. D is, yes, D is right. What would I use here to be able to tell? I check with the vertical line test. And if I draw that, yes, it's going to pass that. And then you also need to check with the horizontal line test. Horizontal line test. And it works for that one also. Only passes through once. So yes, D also works. That's good. What about F? Yes? Let's see. So we got to use the vertical line test again. And yeah, that works for that. It's only going to go through once. Horizontal line test. It's not. Yes. Ah, she caught her own. That's good. All right. So the only two that are one-to-one are, as I have them labeled, C and D. C and D. Questions on that? So if you have a table or if you have ordered pairs, you've got to see, do I have any repeats in the X values? That would be a function. And then do I have any repeats in the Y values? If it's a graph, you do the vertical line test for a function, horizontal line test for one-to-one. Okay? All right. So that was a good one to go over. What about 2 or 3s? Anybody want to see one of those? Okay. Which one? 3, 2, 2. All right. Identify the features. So we're looking at number 2 here. Select all that apply. First of all, class, is it linear or non-linear? Non-linear. It is not a line. It is not a straight line. Function. Is it a function? Is it one-to-one or neither? What do I have to test here? What test do I need to use? Vertical. Yeah, let's try to say vertical first. You know what I'm saying? Vertical line test if it's a function, and horizontal line test for one-to-one. So is it a function? Yeah, I can do a vertical line anywhere through there and it'll work. Is it one-to-one? No, because here we're going to hit 2 places. So it is not one-to-one, and therefore it's not neither. Okay. All right. X-intercepts. X-intercepts. Where will I find the x-intercepts? Omar. Where will I find the x-intercepts? On which axis? On the x-axis. So where on the x-axis does my graph pass through the x-axis? Edward, what do you think? X-intercepts. Usually, sometimes I'll say circle them. What was that? Put them off your ears. No, I liked it better on the table. Yeah, come on. Back on the table, please. Miss Allie. Do you know? If I say circle them, what would you circle? 0 and 4. Excellent. Yes, those are the 2 places. And remember, with the x-intercepts, we don't have to write the second 0. I mean, it is 0, 0, and it's 4, 0, but we don't have to write that second 0. Did I say something wrong? No? Okay. All right, what about the y-intercept? Who haven't I heard from yet? Tiana, what's my y-intercept here? Where does my graph cross the y-axis? 2, -4. Now, that is an important point, but I don't think it's where it crosses the y-axis. So the y-intercept has to be on the y-axis. So if that's the case, can you tell me now where my y-intercept is going to be? 0, 0, or just 0. Yeah. This same point right here. Yeah, you can have the x and y-intercept be the same place. All right. Now, she said something about 2, -4. 2, -4. This thing right here. Why do you think she said 2, -4? Is that kind of a big deal with this graph? Yeah, what is that? It's an extrema, and what kind of extrema is it? absolute minimum. It's the lowest point, okay? Absolute minimum. It's the lowest point of that graph. Now, don't get confused by my y-axis. If you look at just the graph, that's the lowest point, okay? All right, how are we doing? End behavior. As x approaches positive infinity, and we will give you this part that I have written here in black. I don't know why we don't put that, because it's a lot to remember when you're first learning it. But as the x is getting bigger, which means I'm going to the right, what's happening to my graph? It's approaching what? Positive infinity, yes. So that's a sideways 8. And as x is approaching negative infinity, that means I'm going to the left. Look to the left side of that graph. It's approaching positive infinity. Yeah, they're both going up. So that's like YMCA, YMCA, positive, positive. YMCA is a positive place to go when you need help. Think of it that way. All right, this I think is probably one of the hardest things to do. Domain and range. So my domain, those are the what values again? X values. It's going like this. And I want to know how far to the right and how far to the left are these X values going to be covered in my graph. Okay, but we don't say infinity. I mean, it's going to go from forever on the positive side to forever on the negative, right? What do we call all of those things? All real numbers. Okay? All real numbers. The domain several times will be all real numbers. And if you remember, you make 2 vertical lines and then an R. All real numbers, because this keeps going up and out forever. Now, the range, we just said we had an absolute minimum. Your range is how high do you go and how low do you go? Well, what's the lowest this graph is going? -4. So I've got to compare everything with my range, and the range is what values again? X or Y? It's the Y values, right? Do I have a Y value that's equal to -4? Yeah, that's your minimum. So it's equal to -4, and then what else? Is it higher than -4? Or is my graph going lower than -4? Which way? No, -4 is right here. That graph is going up, right? So it's greater than, because this value right here, that's -3. This is -2. This is -1. So it's going up. There? Are you with me? Come on. Okay. Any questions on that first one? All right. How many? Well, do you want to go to the next one, or you think you can do that one? And I will give you the answers and work. Do you want to go over any of them really quickly? Like, is that linear or nonlinear? Yeah. Is that a function? A function? Vertical? Yeah. How about 1-to-1? No. So it's neither or neither. X-intercepts. How many X-intercepts can you have? Question? Yeah, 4 of them. You got 1, 2, a 3, a 4. So that is -2, -1, and I know I usually say don't put these with a comma, but since we have several, we got -2, -1, we got 2 and 3. What is my y-intercept there? Yes, -4. All right, extrema. Extrema. Where do you have some points that are kind of like sticking out? Two. 8:25. Man, we're coming to the end of August. Mm-hmm. 8:25. All right. How about some extrema? Can anybody give me a point that they see as some sort of extrema? What do you think? Yeah, could be 2.5. So we got a 2.5 and I'll tell you what, it won't be this hard on the test. 2.5 and what? Maybe 1.25? Okay. That would be this point right here. Is that an absolute or relative max or min? What is it? Absolute. It's the highest point, right? And it's an absolute maximum. Well, guess what? If that's an absolute maximum, this one must be too. Net coordinates are -1.5. And I would say 1.25. And that is an absolute max. And do I have any more? Yes. What do I have? Yeah, 0.5 and -4.5. That's the point in green. And what would we call this one? What is it? I didn't hear. Relative. Yeah, it's like your relative, you know. Relative minimum. Relative minimum. Okay. All right. So end behavior. As x is going to positive infinity is to the right. My graph is going to, as you go to the right, look at your graph, right? It's going negative infinity. And as x goes to negative infinity, x, that's going to the left, the graph goes to negative infinity. All right. See that? You go to the right, it's going down. You go to the left, it's going down. If they're both going down, that's negative infinity, negative infinity. If they're both going up, positive, positive. It's only when you have one that looks like this, you got to really pay attention, you know, which one's to the right, which one's to the left. Okay? All right, domain. Domain, the x values. So they are going down and out. How far out are they going? What's my domain going to be? All real numbers, yes. Because it's going to keep going out forever. Whoops. All real numbers. And range. That's your y values. Do we have some kind of stopping point, a high point or a low point? Yeah, we do. What's that high point? What did I say it was? 1.25. It will not be anything like that. It'll be much more obvious. And we're talking about the range. It is equal to these 2 points at 1.25. And then all the other y values, are they going up or down? They're going down, right? Here's y is 0, -1. So it's going to be less than or equal to. Okay? Less than or equal to. All right. Well, we got the first page. All right. So seriously, we need to be going a little quicker on some of these. How many pages are we at? 4? Which ones are you not sure of? This is your review. If you're not sure, or maybe if you're pretty sure but not absolutely sure, ask. 6. Okay. 6. Money. The table shows the amount of money remaining in a Starbucks account each month after purchase without refiling. So we have a table with the number of the month and the amount left in the account. All right, the x-intercept and the y-intercept. The x-intercept is blank, the y-intercept is blank. How can we tell when we're talking about an intercept? What do all intercepts have to have? 0. So I know I'm looking at these right here. I just have to figure out which one is which. So what is the x-intercept? What do you think? 4? Yeah, it's 4, 0. Your x-intercept is going to have a value for the x-coordinate and a 0 for the y. So you can just say 4 or you can say 4, 0. And so the y-intercept is 60. I'll put this one in blue. This is 60. So that would be 0, 60. Because it has a value for the y and 0 for the x-coordinate. So this means they purchased how many dollars to begin with? How many dollars did they have in the account to begin with? 60. Okay, that's the amount. And they were going to run out of money in their account after how many months? After 4 months, yeah. Because we're going along, and right here, there's no money, and that is 4 months. And how much are they spending each month? $15. Now, that one might not be quite as obvious, but if when you first put some money on the card, you have 60, and by the next month in, you only have 45, 60 minus 45, okay, gives you 15. And 45 minus 30 gives you 15. And 35 minus 15 gives you 15. Okay? So that's 15 each month. Questions on that? So remember, if it's an x-intercept, could be 0, but only if it's 0, 0 would the x and y-intercept be 0, 0. Usually it's the one that has a number for the coordinate of the x, and it has a 0 for the y-coordinate. All right, what about 7? 7's a good one. A t-shirt cannon. You know, one of those things they put in, it goes, and it gives you a t-shirt. They put it on a 6-foot high platform right here. That is 6 feet. And they launch it at a speed of nearly 1 foot per second. The graph below represents the situation. According to the graph, as x approaches positive infinity, what direction is that? If x is approaching positive infinity, that is to the right. As we go to the right, what's happening to my graph? It's approaching Yeah, this one is kind of crazy because according to the graph, and according to the graph, it's approaching negative infinity. But if we're talking real life, and this isn't really specific here, can a t-shirt go below the ground level? So in real life, it's going to stop at 0 feet. But if you're looking at the graph itself, yeah, it's going to continue to go down. So I would almost put 2 columns here. And going the other way, as x approaches negative infinity, which is to the left, as we're going this way, the graph is going to be approaching what? The graph. Well, the graph itself is going to keep going if it was a math graph. And this is how math answers can be different from real life answers. It's also approaching negative infinity. But in real life, where did it start? Where did the t-shirt start and take off from? 6 feet. So if you go back, it's only 6 feet, okay? What is the maximum height that this t-shirt reaches? Is it? Here, right here is 6 feet. I think it goes higher than that. 10, yes. Right up here. That would be its absolute maximum. So that is 10 feet. Does that make sense to everybody? The high point, it reaches 10 feet. All right. Well, we're not done yet. We're not done. What else do you need help with? How about number 8? Is this discrete, continuous, or neither for that first graph? What? I can't hear you. What is it? It's neither. Yeah, it's not discrete. Discrete are the dots, and continuous, this one is, because it's got an arrow, but this one isn't. So I'm thinking this is neither. It's not discrete, that's the dots. It's not fully continuous, so I'd say that's a neither. What about the second one? Discrete. Discrete is the dots. Okay. And what about the last one? Continuous, because of the arrows. Good. What else do we got over here? What do you want to go over? Quick. What about, let's look at 4. Is that linear or nonlinear? A, 4A. Nonlinear, how can we tell? The exponent has a 3. What about B? Nonlinear, because the exponent of 2. What about C? Linear, there's nothing written. What about D? Linear. Good. Okay. Should we do 5? Order of operations. You got to do PEMDAS, right? Parentheses. If you can do in the parentheses, exponents, multiplication, division from left to right, and then addition, subtraction from left to right. So what would I do first here? Omar. Parentheses. 10 minus 5 is 5. Leave it in the parentheses. Everything else, write exactly as it is. Only do one step at a time. Do I have anything else where I can do in the parentheses? No. Do I have an exponent? What is 2 to the 3rd power? 8. 2 times 2 times 2. Okay, make sure you check that on your calculator. So I would recommend a calculator. Multiplication, division from left to right. What's going to be next? Division, yes. 20 divided by 4, left to right, is 5. 5 times 5 plus 8. Now I'm going to do what? Multiplication or addition? Multiplication is 25 plus 8 gives you 33. Anybody have 33 before we got there? Good. All right, so we didn't get through all of them. 9 and 10 is sketching. 11, we've got graphing. Hopefully you know how to graph. What's my slope in number 11? The slope is 2/3. The y-intercept is -2. And where would you start graphing? At -2. And then you're going to go up 2 over 3. 1, 2, 3. Up 2 over 3. 1, 2, 3. And there is your line. Don't forget inequalities. What kind of a line is this inequality going to have? Dashed or solid? Dashed. And am I going to, as it appears now, am I going to shade above or below? Above. Shade above. Okay. I will have the answers for you sometime after school on Canvas. Also, before I forget, you have a new weekly Canvas activity that you can start. Okay? If you didn't get the one for last week, make sure you get that done. Also, tomorrow is the last day, if you're going to be here taking the test, tomorrow is the last day you can turn in any homework, any bell work that you haven't turned in for this current chapter. So everybody hear me. Okay, so I didn't get too many homework 4s. So make sure you get those done, okay? Homework. Remember, it's mostly completion points. Also, I did give back your skills checks. You might see if you can make corrections on that. Could you improve your score on that? What am I saying? Skills check. Thank you. I was like, All right. Good job today. Surprised you didn't have more questions, but that's the way it goes sometimes.